Welcome to Work on It Wednesdays. This is the fourth episode, and today we are going to look at this question paper, continue from number 2.3. Last week we went up until 2.2. Now 2.3 starts, they say, given this, I've written here, given m is root of k minus 2 over 2k, then they say select an integer value for k, so k must be an integer. Okay, select an integer value for k and state the corresponding m value, so that m is, for 2.3.1, m is non-real. Okay, now for m not to be real, I need this expression under the square root to be negative. So what I want to do is I want k minus 2 over 2k to be negative. Right. And hopefully you know, but if you don't, a plus times a plus is a plus. These things, you know them. Plus times a negative is a negative and a plus is a negative, and a negative and a negative is a positive. Now, most of us know that this works for multiplication, but not all of us know that this works for division also. So if I take a positive divided by a positive, I will have a positive number, etc. Right? So if I want a number divided by another number where both of them is unknown to me, and I want this to be smaller than 0. Smaller than 0 is negative numbers. So I either want my top number to be positive and the bottom to be negative, or I want my bottom to be negative and the top number to be positive. Right? So the k minus 2 is positive for k minus 2 is positive for k bigger than 2. And if this top is positive, I want my bottom to be negative. But if k is bigger than 2, this bottom is not going to be negative. So this is not going to work. Right, so let's look at this one. If my k minus 2 is smaller than 0, so my k minus 2 is the negative one, the top one, then the bottom one must be positive. That means k must be smaller than 2. Okay, now if k is smaller than 2, to keep this bottom number positive, I must also just have k positive, so that 2 times k will still be positive. Okay, so the k values that I'm looking for is k between 0 and 2. Where m is non-real. Now they said k must be an integer. The only integer that lies between 0 and 2 is then k equals 1. And I can just substitute 1, then m will be 1 minus 2 over 2 times 1. Okay, so that is m is root of, this is negative 1 and this is 2. So it's negative 1 over 2. All right. Okay, so my k is 1, m is negative 2. 2.3.2 says a non-zero rational number. So if I want my m to be non-zero rational number, there it is not non-real in this space. So anything between, out of this space, so if I look at a number line, if k is between 0 and 2 there, it's non-real. So I can't really make that k. But for it to be rational, I need to pick numbers outside of this. So any number bigger than 2 or smaller than 0, I can pick. But now I must also make it non-zero. Now this is 0. I can make it 0 by making the top one 0. Then k is 2. 2 minus 2 is 0. Then this whole thing becomes 0. So I don't want to pick 2 either. So that's part of my out of bounds bit. Right, and I can't make k 0 also, actually, because then the bottom one is 0, and that means it doesn't exist. So this is like a no-go zone for me, the 0 and the 2 included. But I can take 3. So if k is equal to 3, then I have m is equal to the root of 3 minus 2 over 2 times 3, and this is root of 1 over 6, okay, which is not rational. Okay, so I'm looking for something that will be rational. Root of only squared numbers will be rational, so this does not work. Maybe I can make k 4. 4 minus 2 is 2. Over 2 times 4 is 8. I think that's going to work. I'm just testing. I'm doing this by trial and error now. So if I make k 4, my m is going to be root of 4 minus 2 over 2 times 4, which is, this is 2 over 8, which is 1 over 4. And that I can actually work out as a rational number. Root of 1 is 1, root of 4 is 2, and that's a rational number, so that works, right? Now, this is not the only correct answer for this question. To make m non-zero and also rational, it must be a fraction. But that's one answer. So you can do testing and test a few to see if you can get a value that works for this. They don't need all values, they just need a value. All right, let's look at question 2.4. Question 2.4 says, consider the equation mx squared minus 12x plus 9 is equal to 0, and determine the value of m if the equation has equal roots. Okay, now for equal roots, if you haven't done this in class yet, don't worry, you'll get to it. But if you know about delta, you have done this in class already. But for the grade 11s, if you don't know about this yet, you will do it somewhere. Delta is just in the quadratic formula, that bit under the square root, b squared minus 4ac. And to get equal roots, I want my delta to be 0. Right? To get equal roots, I want my delta to be 0. So I'm just going to calculate delta first. So that is b squared minus 4a, which is n, and c, which is 9, which gives me, this is positive 144, and 4 times 9 is 36, minus 36n. And this delta I want now to be 0. So if I take the 36 over, I've got 144 equals 36m. And if I divide by 36 both sides, I get 144 divided by 36 is 4. So my m must be 4 to make this equal roots. Okay. Thank you, boys and girls. This was a bit of, it's two funny questions, but if you just stay calm about it and approach them in a logical way, it's very possible to do them. I hope you have a very great week ahead of you. If you come across any interesting questions that you would like to me to do, please give them to me in the comments below. And have a great week. Right.